Good afternoon and welcome to Purdue University and the CERIAS Computer Security Seminar. Our speaker today is Mummoorthy Murugesan. He's a PhD candidate working with Professor Chris Clifton. His topic today will be providing privacy through plausibly deniable search.
Oh, thanks, Randy, for the introduction. Good afternoon, everyone. I'm a PhD student, and as Randy said, in the computer science department. Here I work with Professor Chris Clifton. In today's seminar, I'm going to talk about web search privacy, how to provide users privacy in web search with a technique called Plausibly Deniable search. Okay, before we start, this small piece of a news article says what Google does with the search queries it collects over time, and does it combine the query logs with other information it has on you. So this is just to show that there's a concern among the public about web search privacy. Okay, in August 2006, AOL, American online company, released the web searches of its customers for basically research studies. The query log that they made public had almost 20 million queries of 650K unique users. So the anonymization they did was to replace the user ID with a random number. Okay, that's what they did. And the query log contained a timestamp and actual user query, and also the URL they clicked after getting the results. It happened that the anonymization they did was not sufficient. A New York Times reporter was able to successfully identify an individual who issued these queries. And some of the queries included 60 single men and landscapers in a particular area in Georgia. And also other queries included many specific information, so that that particular individual was identified by this reporter. What happened after that? It was an unfortunate incident, but it also created a lot of awareness about web search privacy, and the AOL fired the CTO because of this issue, and 2 researchers were forced out because of this problem. Okay, so what are the 2 approaches to handle web search privacy nowadays? So one is through server control privacy. The Google or Yahoo is taking care of the privacy of web search queries. So the first type, the search engine promises that, okay, I'll delete your queries after some time, or I'll anonymize the query log before backing up, after 9 months, after 12 months, etc. This is the normal procedure followed by companies such as Google, Yahoo these days. The other option is to use private information retrieval, in which the search engine will not know what exactly you're searching for. But what's the problem with that? It will affect the advertisement business model we have today, and okay, this solution is not going to work. Okay, so, and also we know that the search engines, they want to keep the query logs for a long time, right? That's what they are doing, and so that's what it's making some of these solutions not practical. Okay. The other type of solutions involve the user control privacy, in which the users will use these tools so that their privacy is protected. So there are a couple of tools available nowadays. One is the private web search from Yale University. It provides a complete package to block any metadata that is sent to the search engine nowadays. For example, you get your results and you click on a particular URL that you want to see. That information is sent back to the search engine, and if you use this tool, that kind of extra information that is sent to the search engine will be blocked. So they will, and also using such techniques such as onion routing, you can hide your actual IP address from the search engine. The second tool that is available, which is known as Track Me Not, it's a Firefox plugin that you can install in your machine. It's going to send out random queries every once in a while, so that the search engines will not be able to figure out, okay, what the actual queries are, what the actual user queries are. The idea used here is to use news headlines using RSS feeds and other famous queries. Kobe Bryant is a common query. Some of these search queries will be used as seed queries to construct other queries also. So the idea is that the search engine will not know what the actual user queries are. That's what they want to prevent here. So what is the problem here? You still are releasing your own query. The actual user query is still released to the search engine. That means the user intent is also revealed to the search engine. Okay, so what are the lessons learned here? The information contained in the queries itself, they are enough to identify the user. For example, ego surfing, searching for your own name. A lot of us want to find out how famous we are, right? So we search our own name to see how many pages we are in, etc. And also looks like people search for SSN numbers and credit card numbers. And also how many times you should have searched Pizza Hut and West Lafayette. You might have done it a lot of times. And this applies to medical condition, some of the diseases you search for, and also many other details that you release in search engines are inherently, they can be used for identifying the individual. The second lesson learned is the fact that the query transformation, they transform the given query to something else so that you get what you want. It's not going to give you the privacy that you want. Okay, so what are the privacy issues here in web search? One is the identifiability. So I give you a query log. Can you identify the individual who issued these queries? That's the first question. Who issued these queries? And you can say, okay, this is John Smith, and I know this is Mummoorthy Murugesan because he searched for his name several times over 6 months, right? So that's an identifiability question. Second question is linkability. The use of tools such as Track Me Not. You send random queries from your machine, and that leads to a situation in which the search engine doesn't know, oh, this query belongs to Mummoorthy, or is it a random query, right? So you have a situation in which you have to map a query to the individual or to a particular identity. So here in this scenario, we're asking which queries were actually issued by John Smith. Okay, these techniques that I'm going to explain today is going to protect the users from the first problem, the linkability. That's the main issue that we're going to deal with. And also you have to realize that this is going to affect the identifiability, the first issue also. Okay, so let's move on to the main technique now. Plausibly deniable search. So you can see there are two terms involved, and deniability. So the users are going to submit not one query, k queries. And we have one more property that which is called a reversible property, in which any of the k queries is going to give you the same set that you submitted. So you're going to submit k queries, and any of the k queries will would have produced the same query set. The additional queries that are included as part of your search query are known as cover queries, or masking queries. And also we make sure the way we build this query set, we make sure that these extra queries, the cover queries, are from different topics, not on the same topic that you are issuing your original query belongs to. Okay, second property is the plausibility. Okay, I'm going to issue not one query, k queries. But what happens if all my other queries, the cover queries, are implausible? For example, Java compiler and Newton Apple. Okay, these are two queries that I'm going to submit to search engine. But what about Java compiler and Motorola table? The second query, the Motorola table, looks like completely randomly generated query, right? So the implausible queries will weaken your deniability argument. So in this Java compiler Motorola table example, anyone who looks at these two queries will say, okay, Motorola table is out of the question, only Java compiler is